to give you a background on us and our approach and why we founded the company before I start going into all the details, really the motivation for founding Cloud Signal was we wanted to create a platform that was a public cloud platform, but it gave the end user the same level of configurability and flexibility that they would get from a private environment. So the idea is that it's something like a virtual data center platform, so you can literally just build up all of your VMs and infrastructure and networking and everything else with the same level of maturity and complexity that you would be able to do with physical hardware or a private cloud. So it's really a very different experience to most public clouds, which are sort of a menu-based approach. So it's a customer-driven environment, think of it like that. And then these are some of our customers. So we'd be very lucky to be able to serve some of these large companies, including people like Siemens and Deutsche Börse, or European Space Agency. And so these, what they have in common is they have quite demanding computing requirements, and they see a good fit with how we're kind of exposing cloud resources to them. So now we go into the main presentation. So we hear about DevOps and things like this, and the reality is that everyone makes mistakes, and we've had our mistakes as well. And so what I wanted to do was run you through some of the root causes of issues and outages that we've had, and then sort of how we've gone about addressing them organizationally and also in technology. And because mistakes can turn happy customers into something like this. And if anyone's ever had an outage on a service, you may recognize yourself in that crowd. And I've been on the receiving end of stuff like that when we have an outage and everyone's down, and you have like 1,000 or more people all trying to contact you all at the same time to find out what's going on. So, 4 main root causes that we've seen of outages in the cloud, in our cloud. So the first one is human error, which is probably common to almost any service, but I'll explain how we built our development process now to be more robust. System timeouts and messaging, so I'll explain about kind of the situational lens of our cloud and the challenges around that. That's been something that's caused issues in the past for us, especially as we've scaled up. Essentially, you can imagine components not being able to talk to each other, or being out of sync, or being under a false illusion about something, and etc. So this is kind of all quite a complicated area that's actually really, really critical to delivering a reliable service and getting that right. The third is computing load. So obviously we're a multi-tenant environment, and we have to make sure that sort of a rogue process or a problem or something like this doesn't spread in a contagion type way through the cloud, which can happen. And also that even isolated incidents remain isolated and they don't bring down kind of supporting infrastructure. So if a VM has some sort of rogue process, how do we spot that? How do we stop that? How do we contain that process and prevent it from bringing down the physical machine? Because on a typical box that we have, we'll have like 64 CPU cores in one box and half a terabyte of RAM. And that's in a 2U box. And then you've got like 20 of those in rack. That's a lot of computing in a very small space. And even if one of those machines goes down, that can be anything up to 100 VMs or even 150 in some of these boxes that are affected. That's a lot, and that's just a single machine crashing. So we want to make sure that that can't happen, or it's very rare. And then the final thing is distributed denial of service, DDoS, which is something that we're subject to frequently, and actually more and more people are subject to. And it's also an important thing. If you're on the internet, basically, you will get DDoSed at some point, and so you need to know how to deal with that, because once they start DDoSing you, it's pretty much too late to solve it in real time. Although we did solve it in real time, I'm going to tell you. So the first thing about human error. So I talked, I had Homer up there, and our developers are human like anyone else, and they're busy. And so the key really is that I guess you could argue some people are more reliable than others, but you don't believe there is no infallible developer. So we have to base a system around the idea that they are going to fail and we are going to make mistakes, and we just want to have a process where we catch those mistakes before they go into production. And we've had some decent mistakes. So we had something that caused someone addressed the wrong table in the database, and we caught that partway through the process here. And if it had gone into production, it would have deleted all of the client drives. That's kind of a really scary thing. And when you have problems like this, you realize that having and investing the time in having a proper process is money well spent. And in fact, actually, you don't have a long life expectancy if you don't do it, because at some point you will have one of these catastrophic problems that will destroy the company. So I'll run you through the process of how we work nowadays. And so the humans are little faces. It's where they're involved in the process, and you'll notice they're not involved in the process for the most part, which is the idea. So we use Mercurial, we have the repositories here, and we create branches for more complicated feature sets that we're adding. But anyway, that's the main system that we have, and that sits locally in the Sofia office in Bulgaria. And then we then have continuous integration, so as soon as they commit code, it goes in and it automatically does integration tests and unit tests immediately. So they can see immediately if there are any mistakes. And that's like really critical. All of these things, once we had them, we couldn't imagine why we were doing things without them before. So that's all automated once they push the code. And then if it passes this process, then we start going down into sort of more detailed analysis. And so we'll then